Welcome to the OPI Lifecycle Working Group for November 14th, 2023. A few things. I went to the TSC meeting last Thursday, apprised them of the situation with the named chair, and they've named me interim chair for the time being. As a result, I do have the host code to start the recording, as I have just done. I have another action item to record the meeting minutes from the prior meetings out of Slack into GitHub at some point soon. I think that's it from my standpoint. I believe last week we left things off at we're still discussing mechanics. I'm wondering what's the next steps there and what others' perceptions are.
So which mechanics are you talking about?
Sorry, I was trying to be vague to let you guys try and run with it. We were talking about the reboot mechanics. Well, it'd help if I actually just go look at the notes. There's going to be followed with the PLDM chair regarding standardization of states with the proposed state list.
Yeah, so
we were just, go ahead.
We spoke to Yuval last Wednesday morning, and just what we had discussed and what we put on the webpage, and he understood what we were asking for and was going to go ahead and put that forward as a proposal. It'll take time and there'll be a lot of feedback, but we're going to get started.
I think that's understood. Did we get any sense of how long that process would take?
No.
Well, that's all right.
Yeah, we can follow up this week and see if there's any update on that.
Okay. Toshi, you indicated last week that you're going to take a look at PCIe AER.
Yes, I spent some time looking at PCIe AER. And if I remember correctly, we were discussing about a case when DPU itself would like to initiate a reboot, a DPU reboot, and wanted to make sure it is safe or no impact to the host. And the idea raised last week was if we can use error signal to the host, and that can be handled by the PCIe AR. And the AR could do something to make sure the DPU is safe to reboot or something. And with that, the context, I think the one idea raised last week was if the PCI AR can initiate a host reboot, then it basically goes to the host initiated reboot path, and that can handle basically this case. And I did not see the Linux code initiating OS reboot during the PCIe AR handler. So that handling required additional implementation. So, and I should have mentioned the Linux does support PCIe AR in the PCIe subsystem, So all the AR events are handled by PCIe subsystem first, and it has some default handlers. And also each driver can register their own error handlers for the additional recovery handling. And I cannot speak for the driver-specific error handlings, but for the default handling, it's basically the resetting the PCI link that is causing the error. And I did not see any reboot operation initiated from the AR code. But if the reset is what we want, in this case, then this will meet the goal. So if the resetting the device PCI link, and that goes the reset signal to the DPU and DPU to reset. So that's what we want, that basically we can use the AR. So I wasn't clear about the goal of this operation, so I'm basically describing the behaviors. And another thing I noticed was there is the PCIe hot removal in conjunction with the PCIe AR and the DPC. DPC is the downstream port containment. That is part of the PCIe AR. And this was originally for the NVMe hot removal because the compared to the SATA or ATA disk, the device replacement for the NVMe required a PCIe level removal. And for that, device can generate the correctable errors. And this is also the complex. The DPC has two cases. One is the OS first. The second is firmware first handling. And I cannot speak for the OS first, but OS first is basically everything is handled by the operating system. And firmware first is basically the event is first handled by the firmware. And then triggers the event to the operating system. And in case of the firmware first, if it is the correctable errors, it can generate hot plug event to the operating system, and the operating system can perform the hot removal to the device. This may be used for this particular case. I mean, if the OS remove the device, DPU can reboot safely. So that's, and another, I guess the third case. Oh, yeah, please raise the questions in time. Alok, you have a question? Yeah.
Yeah, thanks, Toshi. I'm trying to recall the discussions from the last week. I think so. What you're saying is about like PCIe AR as an option to basically when an XPU can reboot the host, right, over the PCIe channel.
That was the idea raised last week.
Right.
And
so
what I'm Go ahead.
So will that go via the motherboard BMC, the platform BMC, or is it like you have a direct connectivity channel over the PCIe that can be like leveraged for this type of an action? If I start with that.
Yeah. So this was the case using the PCI inbound signaling. So it doesn't involve the BMC there.
Okay. So yeah, so I don't have much of an idea about this AER option. So maybe thanks for giving the updates, but if you can share some reference material, that would be really good.
Sure. at some point I'd like to just summarize what I found. And I don't know if this approach is feasible or something we can recommend at this point. So because that was the idea raised last week, and I was assigned to investigate, so I did look at, but I did not reach to the conclusion that is something we can recommend or not. I'm just for now, I'm just basically describing what I learned at this point. So the reboot ideas, I did not see the code initiating the reboot from the PCIe subsystem. So what it does by default is basically setting the link.
I would
That
kind of,
should cause the DPU to reset. And if that is what we want, we can achieve by using AER. So I'm not sure what exactly we want to do in this approach. So.
well, I was thinking that AER would be an option if what we're talking about is it's a driver that gets loaded. Loaded for miscellaneous device handling so that can be orchestrated, because not everyone's going to want to be able to do that or necessarily have that level of interaction. And it does require some additional, I don't know what the right word is, orchestration to achieve the actual device signaling the machine to reboot. But for some people, that might also not be a use case. So I think that's maybe it's a good thing to write down and describe. Go ahead, Boris.
So one follow-up on your comment. So you said that the driver should be loaded. Is it something loaded inside the host OS that you are mentioning, right? I'm assuming that's where the additional drivers will be needed, right, to support that kind of connectivity.
So I'm thinking if AER is the trigger that says to the host OS, this card has to be rebooted, and it's going to have to go away. Then we basically have to start triggering the process, triggering hot plug, and or possibly even shutting down the machine, depending on all the unknown details that we don't have an idea of. So there's
also this brings like additional requirements, right, to be supported by the host,
yes,
which is connected to the XPU, versus the out-of-band connectivity option, which is through the motherboard BMC, which I guess today it's being supported by almost all the vendors, right?
Well, the concern with the out-of-band option is it basically, something has to be authoritative in that case, and also only the BMC controls the muxing and the actual talking over the wire to the device. So it's the BMC basically has to be responsible and pull, and then handle all of the business logic required around that. And maybe that's acceptable, but it's also kind of the impression we got from HPE last week or the week before, that basically that was perceived as fraught with risk because of the unknown complexity that would have to be codified inside the BMC. Plus the polling logic that would be required to identify if the BMC needed to reboot. Not BMC, the DPU had to be rebooted. Go ahead, Boris.
So just a couple of comments on the entire discussion. First of all is, Toshi, the downport containment, DPC, and the hot plug of NVMe drives is not applicable to the NICs. So if we're presenting the network devices, that is not going to behave the same. So this is what we see in all our development in Dell, especially in storage, when hot plug of NVMe devices is very easy, while the network cards are not supporting that. So in our experimentation, what we see is exactly that. The handler kicks in, and then the entire server gets rebooted if you hot plug the NIC. So if DPU behaves as a NIC, that DPC and the surprise removal is not going to help us. This is what we learned. So again, good investigation, but we need to double click on this specific area to differentiate between the NVMe drives, which is supporting hot plug natively, versus the network interface cards, which is not the case. Second of all, the second comment is regarding the driver or any kind of agent on the host operating system. Our customers are very clear about not having any presence of any agent and drivers in the host operating system. So it have to be an out-of-band solution for Dell. I'm not saying it's the only solution, but we can support both probably for customers that willing to accept driver or an agent, but there are customers that are not willing to accept that. So out-of-band management have to be one of the options.
So does that mean Dell would find it acceptable to have some sort of piece of logic running inside the VMC that actively polls the device for its status
Absolutely.
and then takes appropriate action? Okay.
I think, again, as a server vendor, this is one of the things we're really strong doing, right? And we have a lot of code, a lot of logic, a lot of business logic in our board management controllers. As servers going into future and next generations is going to be more and more. So I think that's an option. I still don't see a solution, right? So I cannot comment specifically on what that logic would be, whether it's too complicated or not. I don't know because we don't have a solution. And again, we haven't discussed any protocols. So maybe PLDM doesn't allow that, but switching to something else can be good. So, and will allow us, I don't know. Yeah, sorry, go ahead.
But so we discussed PLDM as a possibility.
Mhm.
And the concern largely was because it is all with the I2C bus, it is all the BMC reaching out through the MUX to the device. And
That doesn't have to
that's
be to C bus because going forward, we're using, as we saw, MCTP over USB. So that probably is the right direction in the next generation once all the DP vendors switching to the USB interface on the Goldfingers on the edge connector. So that's, I wouldn't say that this is a limitation always.
that is also a thing that was identified. I guess the concern was what would be the solution in the short term, not the long term.
Yeah, understood.
And maybe the answer is we don't have a short-term solution.
By the way, the short-term solution, nobody's not nobody. I'll speak for Dell. So short-term solution, Dell is not using PLDM today. What we are using is we're using NCSI spec, and Lee published it on our GitHub website, an OPI project, what that NCSI spec looks like. So today we are using NCSI and not PLDM. So short-term solution for Dell is probably continue with NCSI. The long-term solution, we want to switch to probably, and again, probably, I'm not in charge of the program, but probably want to switch into MCTP over USB.
So it sounds like the next steps are really for this entire subject of coordinating device reboots is to just everyone take a piece of the puzzle that they have and sit down and write it out. And then for us to somehow create a combined document on GitHub that explains both where we think we are, where we think we're going, then also here's the PLDM approach that we think could be taken, and then also highlight there is going to be some variation because we expect that realistically end users don't want to deal with drivers or services locally, that there's some of this logic is going to have to live inside of the BMC, and some cases just can't be supported, like the DPU can't tell the OS to reboot.
Also, please remember that we are going back a little bit in time to our initial boot synchronization option. So it takes time for the PCI Express machine on the DPUs to kick in and be stable. During that time, we cannot retrain the link. So even if you're doing like hot plug surprise removal and then hot plug again, or reboot, for example, of the DPU, it will take time until the DPU PCI Express machine will be able to reply with coherent things. This is one of the things why we implemented and talked very extensively on the initial boot coordination through the board management controller when the DPU says when he's ready to continue enumeration, and we hold server basically in reset or in kind of wait state until that happens. Same is applicable in this case, right? If we're saying this is only handled through the PCI Express and we have some kind of driver that's in charge of that, we need to make sure that once DPU reboots, it will take, depending on what reboot it is, but I assume that reboot requires also the reboot for PCI Express state machine, because otherwise probably not very interesting problem to solve. So if that is the case, we cannot just rely on PCI Express because till that time, we are going to receive weird uninitialized responses, or maybe no responses at all. So we don't know what PCI Express replies we are going to get from DPUs, if any, during that reboot stage. So the best thing is somehow to disable that bus, let the DPU reboot, and once we want to reinsert it, maybe it's a different mechanism at all. I'm not sure that rebooting and then immediately hot plugging it after surprise removing is the best way of doing it.
It may also be that this is, in the short term, we just say, we don't see consensus behind the reboot use case or reboot cases. There are additional complexities. We can lay it all out because we have been going in circles in this discussion for a while. And basically try and move on from that point. Because I think it's yes, we can do all these different things, but at the end of the day, how much are customers actually going to need and use? What is that reasonable balance? I don't think we can necessarily be the deciders of that, but unfortunately, I think it's going to have to be market forces and customers ending up voicing their opinions there. Let's
reduce the scope. The most reasonable thing that all our customers are asking for is to have NIC. Let's put DPUs for a second aside. Let's have a NIC firmware updated live. That's the most basic thing. So I think that is the thing I want to reapply to DPUs. I want to be able to update DPU firmware without disturbing the server. If that can be achieved in any way, so this really nails down the problem, I think, to the minimum, to the bare minimum. I want to be able to push the firmware update on the DPU without server disturbance. If that update firmware of DPU will require reboot to the server, this is not going to work for a lot of customers. That is a problem that I want to solve. We can do all the resource allocation and free and all of the additional stuff. We can deal with it later. But for me, the most important part that we have to resolve is how we push firmware update to the DPU without host noticing.
Okay, so there's no coordination with the host. You can't tell the host to like do downstream port containment or anything like that.
I don't know what solution is. If we end up that we have to have some kind of agent and presence on the host, and we have no other solution which is completely seamless, yeah, we'll market it to some customers, and I'm pretty sure that some customers are going to accept it and some customers are not going to accept it. But I would really strive to find a better solution that will not require any knowledge prior to that in the host. Again, maybe we work with all the distribution vendors, we work with Red Hat, we work with SUSE, we work with Ubuntu Canonical, we work with all the major distributions. Maybe we find a solution together, we push something upstream into the kernel, the distribution will pick it up, and then it's all nice and fixed. But somebody have to drive this, and I think this is a forum that can actually make a change and drive it.
So I think the problem that we're going to turn into or run into next is orchestration of the workload, because the workload has to be aware that the device is going away or that it can't pass traffic while chips basically get firmware flashed, unless it's entirely somehow transparent. But at that point, you're also talking about workload switching.
Yeah, but
or multiple
let's
devices.
remember
Which
Yeah,
it still requires the base OS to be aware of what's going on at that point.
I'm not sure about that, because let's think about workloads, for example, right? I'm throwing just brainstorm for a second, right? So let's say the workload is some kind of web server, right? Or some kind of networking application. It already knows how to deal with cables being disconnected, switches going down, packets being lost, delays and congestion control on the networking side. So the application will just experience connection drop, for example. So not all applications, or I would even say most of the application do not care that we rebooted the device. Again, it's not going to take an hour for the DPU to come back. So most of the application will experience network delay or connection drop or something like that.
I mean, I think that it depends on the customer. For example, I've got a customer case someplace in my email from within the last week where someone's networking went down for 23 seconds because they pushed a configuration change. And they're demanding to understand why it happened and what could be done to prevent it. And to them, that 23-second outage was observed by customers. So I think at some point we can't both basically on the spectrum of capabilities and flexibility, we can't have everything. We can't have to say there's somewhere in this entire union where it's the happy place, and there's places where some functionality can't happen. And
correct, but there are managed cases and unmanaged cases. Firmware push, the new firmware push is 100% managed case, right? Somebody decided to deploy a new firmware. You're going to expect some kind of disturbance. Either you want to drain your server from the workload and do something like that. It's up to the application at a higher level, for sure. I agree with you. Some cases are unexpected when DPU reboots because of the kernel crash or firmware bug or something like that, and we cannot orchestrate that. It's not unmanaged.
Yeah, and I think the managed, in the case of someone triggering something or some process triggering something, then all the issues I'm worried about would be able to be handled. And that's going to be specific based upon the context in which that happens. Whereas the unmanaged, those are kind of things we have to work through, I think. And I think that's where we could use AER as any device possibly having a fault to signal a machine to hopefully reboot. That also might not be ideal, but if all storage and all networking is across the same device, then there may not be the ability to save that state.
I'm with you. We need to move forward on this. We are circling around and without any solution. Again, if we can have a solution out of band and figure out who implements what and how, and then we can have another solution, maybe in band, in parallel, and then we give a choice for server providers or customers or DPU vendors to choose what they implement. That's fine by me. Maybe we'll find deficiencies in any of the things, but we need to design. I think the next step is to design the solution, how this can work. How can we push the firmware update into the DPUs without disturbance to the server?
I think there will always be a disturbance to the servers, but that's an orchestrated action. Like you apply firmware update, you're going to possibly do something that may cause an interruption.
But that works today for NICs. I don't see a problem, Julia, to make this works for DPUs, right? It works for NICs best, right? We can push firmware updates to the NICs reboots, right?
But you're reprogramming an FPGA or an ASIC at that point, correct?
Flash, why ASIC FPGA? Like Braha, right? The Connectix. I can push the Connectix firmware. Server is not going to reboot on me.
Right. Mm-hmm.
So the same. I want the same experience with DPUs.
So when you say just push to the firmware, are we talking about firmware on next power on, or are we talking about applying new running firmware?
No, next reboot. No next reboot. I think live.
So basically hot plug new firmware.
On the NICs, yes, that works today. And Lee, correct me if I'm mistaken, you are the expert in this field from now.
I'm afraid it doesn't work that way.
Yeah, there was like a live patch thing that was there, but the problem is it violates security principles. So if you have a monolithically signed firmware, there's not a way to patch it without bypassing that validation. So you end up with
The NIC reboots, the server doesn't have to reboot. I'm not saying NIC is not rebooting.
you can't so we don't really support hot plug for NICs on general servers. So you could do that with an NVMe device, but you can't do that with a NIC very well.
And you're saying they can't really be done on a NIC because hardware root of trust can't just go, I immediately trust you.
I'm saying you can't. Okay, all right, sorry.
Go
You
ahead.
have to reboot. In general, you have to reboot because you have to reload all the firmware, right? Because hardware root of trust is going to make the way firmware is signed right now is signed as a monolithic image, right? There was a little interim period where security wasn't so important, and there were people had played around with live patching, kind of like you monkey patch in Python, right? Live patching, or I think there's even kernel support or people live patch the Linux kernel too, but you could live patch firmware, or people were playing around with that. But then that all died for security reasons. So there's not a good way to do a firmware update without restarting the NIC, and then it is possible with some driver coordination and such to basically say, like, if the driver, you can let the driver know and kind of quiesce things or have it hold things and then rediscover and come back. But I'm not sure that that's like a generally available feature.
I mean, to have that, we basically going back to like AER discussion, and then it would have to be a driver loaded into the host OS to be able to do that coordination, or at least work the kernel side of that coordination.
There's enough that gets reset when you update the firmware that you have to have some driver coordination, I guess is kind of the way to say that. Right. And it all depends. See, so some firmware updates, so some pieces of firmware could probably be updated without resetting everything, but some does, right? So, and it's going to depend on vendor by vendor and architecture by architecture. Trying to say that in the most generalized way without getting into specifics of different.
I think it makes sense. What we need to do is we need to write all this down. In words that people can read.
There's already work being done. Like, so for example, the standard around this is PLDM firmware update, right? And when you do a PLDM firmware update, the device that's being updated can respond back and tell you whether or not like a reboot's going to be required, whether, it's staged and all that kind of stuff, right?
Well, it seems that we do need to write all this down. We need to write down the cases we expect to work. We need to write down the cases that we expect won't work, and then kind of codify the short-term paths, the long-term paths, what we expect hardware vendors to probably have some logic for inside their BMCs to support various use cases, and then also try and find a happy medium in terms of drivers and anything being aware inside host operating system, because to support the more advanced cases of interaction with the hardware, something is going to have to be there on that side to be the other side of it. That is, if it's a use case we care about, or if it's an interaction we care about. And it sounds like there's varying levels of care and desire for certain specific actions or features to be effective at certain times, and we probably need to capture that as well. This would be a nice thing to have, or we'd really like it to see this, but here's also the things we need to be aware of.
Yeah, I think
Feels like
we need to articulate the requirements, and if the requirement be in the firmware update, and also the requirement is we shouldn't disturb the customers on the host side, then using the out of band seems to be out of the option, because from the BMC we can either initiate shutdown or reboot. That obviously disturb the customers on the host environment. So
it's almost like we need a set of principles and capabilities.
yeah, when I was looking at PCI AR, it wasn't clear to me what exactly we wanted to do. So I think the articulating the requirements and behavior help us define what we need to do.
Who would be interested in collaborating on such a write-up?
So, Boris, question: when you were saying firmware, were you including like user space code and things like that, the application code running on the XPU?
I don't think so, because in that case, it's much easier case. In that case, you can probably, if you're not touching PCI Express machine code, you will not see any hot plug surprise removal, probably, because many of the vendors, not all of them, implementing PCI Express in firmware. So if you're just, even updating kernel or for sure user space application, there is not going to be surprise removal on the server side due to that action. So I was targeting a more hard use case. If we can solve that, we can solve everything, right?
Right.
You need to update the firmware that is basically responsible for the PCI Express machine as well. And if PCI Express machine is software defined, like some vendors that we know of, that always.
Yeah. That's definitely the hardest case.
I mean, depending on the end user security awareness and practice and procedures, you might still end up crashing the machine, just because you'll end up possibly changing the measurement of the system itself if they're repolling the state and firmware and putting checksums on as they're running.
Oh, you're saying if they're using some kind of like a TPM kind of thing and collecting.
Yes.
Yeah, that would. Yeah, it runs in the same security kind of problems, right?
Yeah, and there are projects out there to do running measurement through the TPM of the device's firmware in case something happens to the machine while it's operating.
But I mean, you would, so if you support hot plugging, right, then you'd have the same kind of problems with you hot plug an NVMe drive. Those also have firmware. You could run into that solution would have to accommodate that if you're going to accommodate that. Yeah.
I mean, it's probably all or nothing, and it's kind of the same root problem, really, of what goes back to what are the use cases, what are the patterns. As a next step, I think it'd be good for us to try and write all this down. I'd like to try and collaborate with a couple of people to actually try and capture as much of this as possible, so that we can basically reach a consensus on what we think the short-term options are, what we think the long-term options are, what would be really nice, what are things that we would really like to see but may never be possible because of the following items and considerations and constraints, and use that as basically our here are what our requirements are, and here's where we can easily go, and here's where, yes, there are harder things, but they are problems that we either need specific subject matter expertise in, or that we need to possibly see if the paradigm can be changed completely, or if we're up against an immovable wall, just go, we don't think this can be changed realistically based on the current state of architecture.
Yeah, it sounds good. You got also, if you get a list of requirements, they probably need to be prioritized and such, right? So
I think just creating a list would probably be a good starting point. Yeah. And kind of, I like Boris brought up the firmware update aspect, because that is a really hard problem. It does introduce a lot of variables. There are limiting factors. There are things that we probably can't pull off with that, but it does force us to think. So I guess I'm taking the action item of starting something and working on getting that up to GitHub.
okay.
Anything else?
I don't have anything for today.
So I guess to summarize, we'll hopefully find out. We'll hopefully have our expectations set next week with an idea of maybe how long it might take PLDM to standardize upon additional state fields. And hopefully next week we'll have something to reach further consensus on all these loose ends and use cases that we probably need to support, or that they may be interested in supporting.
That sounds good.
Okay, well, if no one else has anything else, we can probably adjourn for the day. Thanks,
Thanks.
folks.
Thank you.
Thank you. Bye.